Learning goal number 15. We're going to be taking a look today at Pythagorean theorem. It's something that you probably saw last year in grade 8. And so we're just going to kind of go over it, do a little quick review, and then we're going to do some practice on how to use Pythagorean theorem and how to come up with our answers. So a couple things we're going to take a look at first. Number one, a little bit of review. A triangle, again, is a three-sided shape. Now, a three-sided shape also has three corners, which we can also call vertices. Okay. This is all stuff that the vertices stuff, we don't have to worry too much about the corners, but the angles. We'll do more of that in grade 10 when you get there, and then we'll start taking a look at how do we solve for those. Today we're just, or in this lesson and now in grade 9, we're just going to take a look at the side lengths. Now, one specific type of triangle is called a right-angled triangle. And a right-angled triangle is one that has a 90-degree corner in it. Okay, and so this is very important to remember that all triangles have three corners. Depending on the size of the angles, depends on the type of triangle we have. If it has a 90-degree corner, then it is what we call a right-angled triangle. In this lesson here, we're going to focus on finding the lengths using these right-angled triangles. Now, a right-angled triangle has three sides. Again, two of them are attached to the right angle, the 90 degrees, and we call these sides legs. Okay, so these are called legs, and they're attached to the 90 degree. Now, if we take a look at this triangle right here that we see on the side, it has this little box in the corner. This little box represents 90 degrees. So that's how we would say 90 degrees. Instead of just putting the 90 corner in there, we would actually just put a little square in there. It represents that it's 90 degrees. And we have two sides that are touching those, and those two are called legs. So we have leg 1, we'll call it leg 1, and here we would have leg 2. Okay, so we'd have leg 1 and leg 2. Now the third side, okay, this last side here, which is not attached to the 90 degree, is also what we could consider to be the longest side, is called the hypotenuse. Okay, it's called the hypotenuse. This is our long side. It's the side that is not touching the right angle. Hypotenuse. Let's make sure we spell it right. Great. Oh, okay. So we have the two legs, leg 1 and leg 2, and the hypotenuse. Now the two legs are interchangeable. Really, it doesn't matter kind of which one we look at. They're interchangeable. This could be leg 2 and this could be leg 1. Okay, that part doesn't really matter. It is the fact that we have two different legs and they're both attached to our right angle. Now, so that's just a little bit about that labeling. Now, the sides of the triangle have a very unique relationship involving these squares that I've shown here on the right. Okay, so I've drawn out a right angle triangle here, and we have squares on the right here. Now, the diagram that we have, okay, the diagram that we're showing here has three side lengths. One of them is 3 boxes long, one of them is 4, and one of them is 5. Okay, so this leg here, which we might want to call leg 1, is 3 boxes length. This one is 4, and this one is 5. Now these boxes are the same length. Okay, so I've taken them all, I've drawn them out to be exactly the same length. And we'll notice here that each of them has, I've kind of drawn a square on the side of it. Now, for each side, a square has been made that matches the side length, okay, of the side. Okay, so here we have a side length of 3. We have a square, a 3 by 3 square. Side length of 4, 4 by 4 square. Side length of 5, 5 by 5 square. The two squares which are attached to the legs of the triangle have the same area combined as the one that is attached to the hypotenuse. Okay. So it's the same one that is attached to the hypotenuse. So you'll notice here that this one has an area of 9, this one has an area of 16. If we put those together, then it equals this total of 25. And that's very key in remembering or what this relationship, and will help us to find side length of certain values. So we could think of this. I'm going to call this 1. This one will be 2, kind of going from our legs. And this one I'll give the title 3. Okay, so square 1, square 2, and square 3. And if we look at that, square 1 plus square 2 equals square 3. Okay, so the areas of all of these two add up to the third one there. And we'll keep that on there as we keep on going. Now, to find the area of a square, we're multiplying the length of the side by itself. So remember that when we want to find the area of a square, it's like 3 times 3, so it's length times length. And another way to show that would be to say length, it's the length squared. Okay, so we can say it also as it's the length squared, or it's the length times itself, length times length. Now I'm going through this because we're going to show a little bit of a proof on how we come up with Pythagorean theorem. A right angle triangle. Okay, so let's just put that off the side. We're going to go back to our triangles here. A right angle triangle will generally be listed with 2 side lengths, or with 2 side lengths given. And for for the sake of creating what we're going to call an equation for this here, the triangle is going to be labeled with sides A, B, and C. Okay, so it's going to be labeled with A, B, and C. Those are going to be our 3 triangles, our 3 lengths that we're going to be using. Okay, how we're going to label them here? We're going to start with C. C will always be the hypotenuse, and I'll do that in a different color. In 1 second here. There we go. Okay, so as I mentioned, C will always be listed as the hypotenuse. Okay, therefore C will always be the longest side. Okay, so C is the hypotenuse, therefore it's always the longest side. It's always our biggest number. And that's going to be there, right there on our triangle. And then our other ones, A and B, are going to be the 2 legs. Now again, like I said, you've probably done this last year, and so it should be fairly straightforward. These can be mixed. Okay, so we could do A here and B there. As the order of the labeling of the legs does not matter. So we could have A and B, or vice versa. We call that B and that A. It really doesn't matter. Okay, but it's important that we understand how we label these off, and it's important that we go through that because to solve for one of the sides, we need to make sure we have it labeled. A and B are the legs, and C is our hypotenuse.